million years, slowly but surely, the granitoid protocontinents grew larger. On different parts of the globe, granite crust appeared that would one day form the hearts of the major land masses. The dominance of the oceans was over. The continents. The planet's very appearance was dramatically altered. As the iron left the oceans, they changed from green to blue. When the oxygen moved on to the atmosphere, it diluted the remaining thick carbon dioxide and cleared the air. $1.5 billion years ago, planet Earth was almost 3 billion years old. For the first time in its history, it was beginning to resemble the planet we know. Newly arrived oxygen had turned the oceans blue, and the continents had grown to cover nearly a quarter of the surface. But their expansion was not over, and beneath the oceans, deep forces were at work, rearranging their positions.
On the other side of the Atlantic Ocean.
The freshwater Paradoxides could not have swum the vast salty ocean. And they were not the only fossils showing bizarre intercontinental distribution. His observations in Greenland convinced him this continental drift was possible.
I think
the fractured network of submarine mountains, volcanic rifts, and trenches that split the oceans into enormous plates of crust. These plates would be the building blocks for the new science of plate tectonics. The rifts and trenches would provide a solution to how continents drift by proving that the ocean floors are continuously being recycled.
plate tectonics is completely driven.
Deep below the surface, mobile mantle rock is in continuous circular motion, following convection currents of heat generated deep within the planet. Where these currents rise, the rifts form and the plates are pushed apart, with new ocean crust created in the gap. Where the mantle currents sink back down into the Earth, they drag old oceanic plate down with them towards the interior. As the ocean plate moves, so do the continents.
That oceanic plate drags the continent along.
The process of ocean creation is to a time of a mass continental collision. As the oceans between them were swallowed up, the large land masses drew together in what was to become a supercontinent, Rodinia. It is believed that Canada and the USA formed the supercontinent's heart, with other continents bunched around them. 400 million years ago, the Earth is more than 4 billion years old. Over the next 100 million years, the continents would once again converge. And this time, thanks to the ozone shield, life was free to leave the oceans and conquer the land. Planet Earth had become a world of tropical swamps. 250 million years ago. For hundreds of millions of years, life on the surface had faced numerous challenges to its survival, but nothing on the scale of what was about to happen. In what would one day become Siberia, the Earth's crust became a volcanic morass. The cause was a rare mantle plume eruption. No one knows for sure why they occur, but occasionally, huge masses of hot mantle from deep within the Earth surge upwards, melting and smashing the crust above. The eruptions continued for over 1 million years. They spewed out over 1 million cubic miles of molten rock. In enough to bury the modern USA in a layer over 1,000 feet deep. Clouds of poisonous gases spread out and shrouded